Hi, my name is Leticia Amador-Angulo, and I talk about big colony optimization algorithm to tuning membership function in a type 1 fuzzy logic system applied in the stabilization of a DC motor speed controller. We start for the abstract. In this paper, a big colony optimization algorithm is present particularly in the designing of a type 1 fuzzy logic system to find the optimal values of the membership function with the goal of stabilization a DC motor speed controller. An individual B presents two types of rules, big scope and big following. Each role is analyzed in the intelligent behavior of the bee to find the food is simulated in a real problem control applied to the fuzzy logic controller to stabilize the speed of 4 rats through starting at an original point. These metrics are analyzing for finding the optimal value that affect in the efficiency of BCO algorithm. The comparative analysis with BCO algorithm is with harmony search, chicken search optimization, and differential evolution. For the introduction, some problems starting with the BCO algorithm. Several authors is interesting for the application and implementation for the BCO algorithm. You can see about 7 reference important that work did algorithm. The related words in the real problem study is called DC speed motor controller. Several authors is interested in this problem. For example, the reference number 8, 9, 10, 11, 12, and 13. Theodorovi in 29 creates the newest bias pairing algorithm based on behavior of bees to find food called big colony optimization algorithm. This algorithm is based to the create of multi-agent system capable to successfully solve problems. Every artificial bee proposes one possible solution in the problem. You can see for the representation in the nature this algorithm. The image number 1 indicates the general idea for the BCO algorithm to solve control problem. The image number 2 illustration step to step in the BCO algorithm. You can see two fast, forward, and backward. The dynamic of the BCO algorithm is shown by equation number 1, 2, 3, and 4. For example, the equation number 1 indicates the rentability for the B. The equation number 2 indicates for the wiggle dance that 1B indicates in the algorithm. The equation number 2 indicates the rentability for the 1B. And the equation number 4 indicates the rentability for the colony. The problem statement present is called DC speed motor. Is very popular in the control controllers. The image number 3 indicates illustrate the initial state of the reference. A real control problem in is illustrated for the image number 4. So they proposed the main idea for the fuzzy logic system in 1965. Mamdani in 1974 proposed a case of fuzzy controller to implementation of the fuzzy logic system. You can see the image number 5 shows the graphic description of a Taiwan fuzzy logic system. And the question number 5 indicates the mathematical representation. The design of the proposed Taiwan fuzzy logic system consists in 2 inputs, error and change error, and 1 output, voltage. The proposed fuzzy rules for the Taiwan fuzzy logic system consists in 15 rules. And the image number 8 indicates the distribution of the values in each member's function. The size for the vector solution has 49 values. Table 1 show the main values in the parameter for the B-colony optimization algorithm. For example, the population, the follower B, the alpha, the beta, and the iterations. In this case, the fitness function is found for the root mean square error, representing for the equation number 7. In 5 control, other important metrics to evaluate the good performance for BCO algorithms are shown by the following equations. The table 2 indicates the final errors for the BCO algorithm for the metrics B's, worst, average, and standard deviation. The table 3 indicates the comparison between the 3 important bio-sparring algorithms. Best behavior on the result is proposed for the image number 9. And image number 10 represent the speed response in the real problem with the BCO algorithm. Finally, conclusions. The main conclusion is highlighting the efficiency of the proposed algorithm based on a real problem for the fuzzy controller. And stabilization and the speed is shown on the results. An important analysis in the comparative with 3 metaheuristic algorithms was proposed to relate with chicken search optimization, fuzzy harmony search, and fuzzy differential evolutions algorithms. The main conclusion is to analyze that the BCO algorithm obtained excellent results with the finite functions metric. One strategy to improve this research is to aid perturbation disturbance in the fuzzy logic controller with the main objective of exploring in grade the results of the BCO algorithms. Other idea is to increase the station of the fuzzy sets with the interval type 2 fuzzy logic system and to be able to analyze in more detail the level of the uncertainty in the real problem. This is some results. This is some reference. And thank you for your attention.